My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Many years ago, some civilizations needed better numbering systems to help them describe their situations. Thus, humans invented different counting systems to help them understand and describe their world. Imagine if you could only count to two, and every number larger than two was labeled many. Now imagine that you raise chickens for eggs and want to trade them for another good, such as corn. You could exchange one egg for one ear of corn, or two eggs for two ears. After that, how would you know what is a fair trade? Someone could trade their many ears of corn for your many eggs. Wait, how would you know how many eggs you had in the first place? Obviously, humans needed ways to represent large values, even just to count. In the United States, we use the most common counting system called an additive decimal positional number system. Additive means that we add the values instead of multiplying them to get the total value of the number. Decimal means the numbers are based on 10 symbols, and positional means that the location of a digit is meaningful. In our number system, we need to understand the symbols 0 to 9 and each position's meaning. Both determine the value of a digit. When we know the value of each character, we can add the values together to get the total value of the number. Understanding our number system is tremendously important because we need to understand the values of many types of numbers. Not understanding place value means you could make the mistake of writing a check for the wrong amount or putting the wrong number of items somewhere they don't fit. While we often use place value to understand numbers directly, we also use place value to estimate, an even more valuable life skill. Place value is essential to calculating too. Understanding place value is part of understanding our numbering system. It is imperative to know about numbers so you can interact with the world around you. When we start learning about numbers, we begin with the values 1 through 9 as we learn to count. Then we add 0, and later add the numbers 11 through 19. These numbers have unique names that we must learn. When we move a number from the ones position into the tens, its value is multiplied by 10. Being in the tens position means a digit is 10 times what it would be if it were in the ones position. This is why we say its location has value. A number's value depends on its position. We can represent some values using base 10 blocks. When I represent values in the ones position using the unit cube, the rod represents the tens position. The rod is a group of 10 unit cubes. Digits in the tens position represent groups of 10. Digits 2 and larger have the following names when located in the tens place. If we decompose values with a digit in the tens position, we multiply the number by 10 and add it to the values in the hundreds and ones places. Let me show you a few ways place value gets used in Georgia. An example is 91, which I will write in 4 ways. I will begin by writing the value on a place value chart. Starting on the left, a 9 is in the tens position. There are 9 groups of 10, which can be represented with 9 rods. To decompose the 9's value is multiplied by its position, 10, for a product of 90. We write this as the word 90. Next, I move to the right to the 1 in the ones position. 1 unit cube represents this value using base 10 blocks. The ones value is multiplied by its position, 1, for a total of 1. We write this as the word 1. Therefore, 91 can be represented by 9 rods and 1 unit cube, decomposed into 9 times 10 plus 1 times 1, and written out or spoken as 91. There are at least 91 species of mammals native to Georgia. It is also vital for us to be able to represent numbers in the hundreds. Moving numbers to the hundreds column from the tens column means multiplying by 10. Numbers in this position are represented using the flat in a base 10 block set. The names of values in the hundreds position follow a pattern. We state the number's name, then the word hundred to indicate these values. When we decompose values with numbers in the hundreds position, we multiply the digit by 100. We add this value to the amounts in the tens and ones positions. Georgia's birthday is February 12th. In 2023, Georgia celebrates its 290th birthday. I will represent this number in four ways. First, this number can be written on a place value chart. A 2 in the hundreds position can be represented with two flats. Multiplying the digit by its position gives 2 times 100 or 200. Its value is written in words as 200. Next, I move to the 9. Digits in this position are represented with rods, so 9 rods are needed to depict this value. The 9 is in the tens position, meaning its value is 9 times 10 and is written as 90. Finally, the last digit is a 0. Writing the 0 is critical, but we do not represent it with images because 0 means no value. We also do not write or say zeros. However, we can express its value by multiplying 0 by its position. In this case, that is 0 times 1. Altogether, we get a visual representation of 2 flats and 9 rods. We decompose the value as 2 times 100 plus 9 times 10 plus 0 times 1. And we write and say the value as 290. For almost 300 years old, Georgia is looking pretty good. Try this one. Georgia has the second most counties in the United States. Represent the number of counties in a place value table as a visual representation using base 10 blocks, as a decomposed number using place value multiples, and in words. The number of counties in Georgia can be written like this in a place value chart. I use 1 flat, 5 rods, and 9 units as base 10 blocks. Decomposed, I can write 1 times 100 plus 5 times 10 plus 9 times 1. In words, the number can be written as 159. Moving past the hundreds place, we can extend the place value chart as follows. 10 times 100 is 1,000. 10 times 1,000 is 10,000. And 10 times 10,000 is 100,000. Numbers in the thousands position and greater work like numbers in the hundreds position and below. While base 10 blocks can only represent numbers up to the thousands without some imagination, decomposing them and writing them is like what we've already seen. When we write numbers with more than 4 digits in standard form, we write commas to separate the numbers into groups of 3 to make them easier to read. This is done in the United States. Other countries may use a different symbol or group differently. Take the year the first woman graduated college, right here in Georgia. Catherine Brewer Benson was the first woman in the world to receive a college degree. Here is the year she graduated from Wesleyan University in Macon, Georgia. While years are usually spoken differently, let's consider this a whole number instead. I can write the number in a place value chart to begin with. Representing this value with base 10 blocks, I need 1 large cube to represent the 1,000. Then 8 flats mean the 800s, and 4 rods represent the 4 tens. There is a 0 in the ones position, so I do not represent it with base 10 blocks. Decomposing the value, I get 1 times 1,000 plus 8 times 100 plus 4 times 10 plus 0 times 1. Writing the number in words is 1,840. Try this one. Georgia's highest point is in the Blue Ridge Mountains. Brasstown Bald is this many feet high. 1 mile is 5,280 feet. Is the mountain taller or shorter than a mile? To compare these values, I will write them both in a place value chart to see the digits lined up and know the value of each position. I look for the furthest left column with digits. Since both values have a digit in the thousands place, I will compare the two numbers. Georgia's point has a 4 in the thousands place. and a mile has a 5 in the thousands place. Therefore, the mile is greater. The mountain is shorter than a mile. Adding more values to the left side of a place value chart is done by multiplying the column to its left by 10. We can extend the place value chart by multiplying the 100,000 place by 10 to get the millions place. Continuing gives us the 10 millions place, 100 millions place, billions place, and beyond. In 2020, Georgia had over 9,953,730 acres of land devoted to agriculture. Represent this number in standard and expanded forms. In standard form, I would write a 9 in the millions position and in the hundred thousands place. I write a 5 in the 10,000s position and a 3 in the thousands. Then I write a 7 in the hundreds and a 3 in the tens position. A 0 is placed in the ones position. Finally, I add commas to group the digits into sets of 3 from the right side. In expanded form, the number is 9 times 1 million plus 9 times 100,000 plus 5 times 10,000 plus 3 times 1,000 plus 7 times 100 plus 3 times 10 plus 0 times 1. Notice that moving right on the table means dividing a place's value by 10. If we continue this process with 1, we get 1 divided by 10, or the fraction 1/10. This fraction represents a value less than 1 but greater than 0, a part of a whole amount. Digits in this position represent the number of tenths. Notice that a decimal separator dot is added to the right of the ones position. This is to indicate that part of a whole is included in the number. Dividing 1/10 by 10 gives 1 over 100, or 1/100th, and the hundredths place. Notice the TH sound at the end of the names of place values representing decimal values. Pronouncing and writing the TH is an essential distinction between whole values and parts of whole amounts. We often use values in the tenths and hundredths position when dealing with money. However, money is read differently than general numbers. For example, in 2022, Georgia's minimum wage was $5.15 per hour. Reading this as a number, I get 5 and 15 hundredths. Decomposing this value gives 5 times 1 plus 1 times 1/10 plus 5 times 1/100th. It is less than the federal minimum wage. By law, you earn $7.25 instead. Reading this as a number, I get 7 and 25 hundredths. Decomposing this value gives 7 times 1 plus 2 times 1/10 plus 5 times 1/100th. However, if you live in Washington, D.C., you will earn the highest minimum wage in the United States at $16.10 per hour. Reading this as a number, I get 16 and 1/10. Decomposing the value gives 1 times 10 plus 6 times 1 plus 1 times 1/10. Notice some differences in the examples involving values to the right of the decimal point. The word "and" is spoken and written between the whole number component and the fractional component. The first place to the right of the decimal point is the tenths place, unlike the ones place to the left of the decimal point. When we say or write values to the right of the decimal point, first we say the whole number name of the digits behind the decimal. Then we use the position of the rightmost non-zero digit, making sure to pronounce the TH at the end. At one location outside of Savannah, Georgia, a total of 31 and 765 thousandths inches of rain fell in a year. How would this number be represented in standard and expanded forms? In standard form, there is a 3 in the tens and a 1 in the ones. The word "and" indicates that values smaller than 1 are included, and a decimal point is needed. 765 thousandths means the digits 7, 6, and 5 are to the right of the decimal point. The last digit, the 5, is in the thousandths place. Expanded, we get 3 times 10 plus 1 times 1 plus 7 times 1/10 plus 6 times 100th plus 5 times 1,000th. In the US, we use an additive decimal positional number system. This means that the 10 digits and their locations in a number are part of the value. The values are added together to get the total value of the number. Understanding our number system helps us communicate effectively and make sense of the world around us. In my mathematical world, I have one little problem. I am helping with a Georgia Day celebration, and I deal with many large numbers to organize it. Help ensure I use the correct values and make good decisions, as I need to purchase large quantities of supplies. I call Ramon, who works in a large distribution warehouse. He tells me if the items I need are in stock or if I need to make a special order to get more. When he answers the phone, he tells me he has already counted the number of chairs, tables, and large packs of paper plates. Write the number of items down if Ramon says he found 573 chairs, 304 tables, and 841 packages of plates. Next, I tell him a few items I know we will need, such as stuffed prizes, candies, beverage cups, and cookies. I know we will need the following amounts. Is there enough in the warehouse, or do I need to order more if Ramon says there are 251 prizes, 818 candies, 362 cups, 107 cookies? For the following items, Ramon says he can tell me if there are enough items in the warehouse if I tell him how many we need. We need the following items. Write out each number so I know how to say it correctly. The food committee gave me a list of items to check so that all attendees could be fed. Using last year's sales, the committee estimated some food items I would need to purchase. Write the following numbers in words so I know how to say them to Ramon at the warehouse. Ramon says he has some items in stock right now that the food committee might want to know about. Write the information down in standard form if he says there is at least 3,025 pounds of lettuce, 4,812 tomatoes, 243,681 packets of ketchup, and 20,166 packets of mustard. Look at the following table that Ramon sent. Write an inequality symbol to show if the number of each item in the warehouse is greater than, less than, or equal to what we need. When organizing just about anything, you often work with parts of whole values, fractions, and decimals. Help me tell Ramon some information by writing out the following values in words. The festival committee determined the average use per person for specific items. Which is greater, the amount the fundraiser needs or the amount in the warehouse? We need toilet paper. Ramon says there is enough for 25 hundredths of a roll per person. We need sugar. Ramon says there is enough for 102 and 6 hundredths grams per person. We need peanuts. Ramon says there is enough for 36 and 9 hundredths ounces per person. Take a look and you will see a mathematical world around you filled with numbers. Because numbers are everywhere, we must understand their values and representations. In fact, because we need numbers to describe and understand, well, just about everything, place value is everywhere. Thus, when you believe in yourself and understand numbers and mathematics, you can go anywhere.